top level block diagram. Here already you have seen up and down logic. Here in this up and down logic, here this is input VCC, present state 0 to 1, UPN VCC to XOR gate, NS1 next state 1. Here present state 1, present state 0 connect to XOR gate, and NOT gate also connected to NS next state 0. Here NS1 next state 1, logic circuit output next state 10, up and down logic PS1 10, next state 10, UPN symbol. Register block. In this register block, D flip-flop clock reset output 0 to 1 vector symbol connect here. D1 input clock connecting, reset button here, and this here. This is output Q1 and Q0. This output Q1 logic circuit. This is the logic circuit. Two bit 4x1 mux. 2 bit 4x1 mux circuit. 2 bit 4x1 mux. Here this is the symbol. Here output 0 to 1 vector, output vector A3, A2, A1, A0 for 0 to 1 vector input, and then set 0 to 1, S of 1 0 1 0 1 comma 0 1 to 0 to 1. Here all are here showing input VCC. Okay. A3, A2, A1, A0 setting. Okay, here mentioning here 4x1. This is the output. Output 1 0 0 to 1. 4x1 mux. Y0 output. This is one output. Y0, Y1 another output. Circuit. One bit 4x1 mux. 1 bit 4x1 mux. A3, A2 input VCC. 1 bit 4x1 mux. This is the symbol. Y is the output. A3, A2, A1, A0 input setting point 0 to 1. A0 to A1, A2, A3. This is the input. VCC input 2x1. 1 bit 4x1 mux. Here symbol 2 cross 1 max 1 bit A S B output Y. All are showing here. This one. Here not gate. Here not gate. Here AND gate. Here OR gate connecting together only with output Y. Output here. Okay. The set point. Not gate no. Set point here. This portion. Top level block diagram. In this top level block diagram, in this top level, in this top level block diagram, up and down logic here, 24 2-bit 4 cross 1 max register. Here output Y is the output. Here UPN input. UPN here present state. Here next state up and down. Here S1 S0 function 0 S1 S0 S1 0 function S1 0 D S0 that is state 1 S1 state 0 S0 state D, then synchronous reset S1 state while S1 state 1 S0 state 1 off function while S1 state 1 S0 state 0, then count. Output function is the count. Here simulation result, timing diagram. Okay. Reset this portion for reset. UPN, this one UPN. This is set point. This is clock. This is output 0 to 1. 500 nanosecond, 1 microsecond, 1.5 microsecond, 2.0 microsecond, 2.5 microsecond, 3 microsecond, 3.5 microsecond, 4 microsecond, 4.5 microsecond. Here reset, when reset here from here always 1. Here UPN 0, after 2 microsecond it will be up to 3 1 here 0 here 1 1 from 3 to 4 here here 0 1 0 1. I am setting with 500 nanosecond 0 while 500 second stop up to 1 microsecond. This one continue up to 1.5 microsecond. Then this one continue up to 4 microsecond. And then this one up to approximately 4.5. Clock. Then clock 1 while 1 it will change 0 to 1. Yeah. 0 to 1 positive edge. Here also. Here also. Here also. Here also. Here and so on. Example is FSM finite state machine controller. State diagram. State diagram. Yeah, state S0 state S10 S1 state S2 state S3 state. Here in S0 state reset 0. S1 state having self self node T S1. S2 node okay S0 node going to S1 and S1 itself T. Here we got 1 okay 1 from S1 to S2 T bar got here 2, then S2 to S3 D for T bar, then S3 to S2 also went in S3 3 okay from S2 to S2 state to S0 state T here 0 okay 0. Truth table for MS. For truth table for next state already we have seen S0 S1 S2 S3 for present state 1 present state 0 T next state 1 next state 0 Y1 Y0 this T okay output to Y1 output to Y0 next state 1 next state 0 okay all 0 here next state 0 ns1 next state 1 0 NSO NS0 sorry NS0 1 Y1 0 Y0 0 here PS1 0 while PS1 0 PSO 0 TG1 then NS1 0 NS0 0 1 Y1 output 0 here also output when output is here 1 will come 1 0 0 1 1 yeah 1 0 1 1 1 0 1 1 when here output will come 0 1 0